Okay, so this is 2-5, solved by elimination. Now, when you have equations, our system of equations, I find this is probably the easiest way to solve. People prefer this over the substitution or the graphing. The steps are right here for you, where you have to make sure the equations are lined up. Like make sure the x's are in a column, the y's in a column, the equals in a column, the constants in a column. You're going to multiply one or both equations by something to make them have the same coefficient in opposite signs, and then solve from there. So I know you've done this before, so it shouldn't be too terrible. So let's go ahead and get started. Say on the first one, notice that they're already in columns, and we just need to get the x's. The x's have the same value, that both have a 1. So I'm going to multiply this bottom one by -1. So the top equation stays the same. Bottom equation changes the sign on all of these. So now when I add these two things together, notice that gives me 8y equal to 24. So now I have one equation with one variable. So I can solve for that, divide by 8, and I get y is 3. So once I know y is 3, then I can plug it into either one. It really doesn't make a difference. I'm going to choose the bottom one because it looks a little bit easier, but you could choose the top if you like. So I get x is -4. So my ordered pair would be -4, 3. Now you can always check these by plugging these back into the original equations and solve, just to make sure that they're true for both of them. But I'm not going to make that mandatory. Okay, so number 2, notice how the y's already have the same number. So, and the signs are already opposite. So I actually could just add these two equations together. So this gives me 8x equal to 64. So if I divide by 8, I get x is 8. So then I'll plug it back into either one of those. I'm going to choose the top one because the numbers look a little smaller. Make sure you plug it back into the right spot there. So if I subtract 24 on both sides, it gives me -2. So y would be -1. So my ordered pair is 8, -1. All right, so let's keep going. Number 3. Okay, notice that this one, this x has a coefficient of 1. Okay, so it's always best to work with those. If you see that, work with those. So I can multiply this bottom one by -4 so that my x's would cancel. So the top equation stays the same. Bottom equation, I'm multiplying every term by -4 all the way across the board on both sides of the equal sign. If you don't do every term, you're going to mess this up. So now I can add these together so my x's will cancel. That leaves me -29y equal to a -58. And if I divide by -29, I get 2. So once I know y is 2, I'll plug it back into either one of those. It really doesn't matter. So I'm going to choose the bottom one because it looks like smaller numbers and less negatives. So I get x is -6. So it's -6, 2. Be sure and put those in the right order. Always x first, y second. All right, so number 4. Notice this one's a little bit more challenging because you don't have one that has a coefficient of 1. So like when we did these, and you know what, I'll highlight these. I saw that these had the y's up here had opposite coefficients. This one had the same number for the x's. I just had to multiply by a negative. But on this one, we don't. So we can either choose the x's to eliminate or choose the y's. It really doesn't matter. You'll get the same answer either way. I'm going to choose to work with these y's just because I see that the 3 and the 6, well, I know 3 times 2 is 6, so I'm going to do that, and I can work with just multiplying this bottom one by -2, so I don't have to multiply both equations. Sometimes you do have to do both equations, and that's absolutely fine. So the top equation would stay the same. bottom equation, if I multiply everything by 2, negative 2 rather, then notice my y's are going to cancel out, which is what I need them to do. So if I add these together, that gives me 3x equal to, what is that, negative 27? Alrighty, and then divide by 3, that gives me negative 9. So once I know x is negative 9, I go to either one of those, okay, it doesn't really matter. I'm going to choose the bottom one and plug in negative 9 for x. So, and solve this. Well, add that 18 to both sides, and that would give me 5. Oh, wow, this one gives me a fraction, because if I divide by negative 3, I get 5 over negative 3. So y is negative 5/3. So it's negative 9 and negative 5/3. I don't like when it doesn't come out nice and pretty, but that's what happens sometimes. All right, let's see the next one. Number 5. Okay, so we can choose to cancel the x or the y, doesn't matter. I'm thinking I'm going to deal with the x's here, because whether I do with x or y, I'm going to have to multiply both of the equations by something, okay? Because neither one goes, something goes into the other. So I'm choosing those because the numbers are a little bit smaller. So I'm going to multiply this first one by 2 and the second one by negative 5. So therefore, I'd have the same value, the same coefficient for the x's, just different signs. So if I multiply the top one by 2 across the board, that gives me 10x plus 6y equal negative 14. And on the bottom one, multiplying by negative 5, that's negative 10x minus 35y equal negative 15. So if I add those together, that gives me negative 29y equal to negative 29, so y is obviously 1. And then I can plug it back into either one of those. I'm going to choose the bottom one. But it doesn't matter, you get the same answer. And if I solve that, let's see, minus 7, it gives me negative 4. So x is negative 2. So negative 2 and 1 is molar pair. All right, so number 6, let's see. Can multiply either one of those. I wonder if I simplify this first, would it make it a little bit easier? Well, you probably won't see that, so I'm not going to do that. Okay, so what I'm going to do is I'm going to look at these x's because the numbers are smaller than the y's. So if I multiply, or want these to be the same, 3 and 4 goes into 12. So that means if I multiply this top one by a 4, well, I'm going to do negative 4 on the top and a 3 on the bottom. Now, it doesn't matter which one you choose to be negative. As long as one of them is negative, they'll cancel out. So if I multiply this top one all by negative 4, then that gives me negative 12x plus 36y equal negative 36. On the bottom, if I multiply everything by 3, that gives me 12x minus 36y equal to 108. All right, notice what happens. The x's cancel and the y's cancel out. So on this side, I've got 0. On this side, I get 72. But that's not true. So that means there's no solution here. So again, this is what it would look like if you were solving using an elimination and you get no solution. If I had graphed these, then they would be parallel lines. Okay, so on number 7, let's see. Notice that they're not lined up. We got the equal signs in the wrong spots and everything, so they're not matching. So let's line them up. So the first one actually would stay the same because it's in standard form. But notice the second one, to get it in the standard form, I need to subtract that 2x on both sides. Now it's lined up. The x's are in a column, the y's in a column, the equals in a column, and the constants are in a column. So at this point, I can decide which one I want to work with here. I'm going to choose to work with the x's because they're already different signs and the numbers are small enough, or smaller than the others. So I'm going to multiply this top one by 2, the bottom one by 5. So the top one by 2 would give me 10x minus 12y equals 6. The bottom would give me negative 10x plus 35y equal to 40. All right, so now if we add these together, the x's cancel, which is what I want them to do. The y's, let's see, that would be 23y equal to 46. And if I divide by 23, you get 2. All right, so we know that's one. So we can go back to any of the original ones. I'm going to choose the first one and solve for x now. If I add 12 to both sides, I get 5x equal to 15. Divide by 5, so x is 3. So this is 3, 2. Some ordered pair. All right, so number 8. This one again needs to be put in the proper form. So let's see. So this would be 10x plus 8y equal to negative 18. On the other, it would be 9x minus 5y equal to negative 4. So notice I had to add and subtract terms to get them on this correct side so they could be lined up. So on this one, I'm thinking I'm going to work with the y's because they have different signs already, and the numbers are a little bit smaller than the numbers that are with the x's. So that means to get these to cancel, I'm going to multiply this top equation by 5, bottom equation by 8. So if I multiply the top one by 5, I get 50x plus 40y equal to, what is that, negative 90? I think so. Okay, on the bottom, this would give me, if I multiply by 8, 72x minus 40y equal to negative 32. So that would give us 122x equal to a negative 122. So x is negative 1. So then I can plug it back into either one of those. I'm going to choose the bottom one. So 4 minus 9 equals 5y. So negative 5 equals 5y. So divide by 5. So y is negative 1. So my ordered pair is negative 1, negative 1. All right. So let's look at the hard ones, right? The word problems. First thing you want to do is define your variables. Like, what are you looking for? Give them a letter. Then you set up your equations and then solve it any way you want. It really doesn't matter if you want to use elimination, substitution. I don't really care. Any of them will work. You can graph it if you feel like it. I don't think you will. Most people don't. Okay, so let's look at number 9. Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? So I'm going to say B is books, and I'm going to do C for CDs. Okay, so let's see. She bought 20 books and CDs. So B plus C is equal to 20. We don't know how many of each one yet, though. Cost, $1.50 for the book, so $1.50 for each book, plus $5 for the CDs, has to add up to the amount she spent. All right, so those are our two equations. I didn't have to put decimals on the $5. I could have just left it 5. Okay, so let's see. I am going to multiply this top equation by negative 1.5 so I can get the b's to cancel. So negative 1.5b minus 1.5c equal to a negative 30. I'm going to bring the bottom equation over. Yeah, you're definitely going to want your calculator for this one. So the b's cancel. So this leaves me 3.5c equal 2450. And if I divide by 3.5, I get 7. So that means there are 7 CDs. And B plus 7 is 20, so B is 13, so it's 13 books that she bought. Not too bad. All right, let's look at number 10. Landon babysits and works part-time at the water park over the summer. 1 week he babysat for 3 hours and worked at the water park for 10 hours and made $109. The next week he babysat for 8 hours and worked at the water park for 12 hours and made $177. How much does Landon make per hour at each job? Okay, so I'm going to let B be babysitting. And W for the water park. So let's see, babysat 3 hours. So 3 hours babysitting plus 10 hours at the water park, and it got him $109. The other one, 8 hours babysitting plus 12 hours at the water park, and he earned $177. So those are our system of equations. So now we solve it. I'm going to use elimination since there's not a coefficient of 1 here. So you can choose to cancel the B's or the W's. I'm going to do the B's just because they're smaller numbers. So I'm going to cancel, get these to cancel. Okay, so that means I'm going to multiply this top one by -8 and the bottom one by 3. Now it doesn't matter which one you put negative, as long as one of them's negative, you're in good shape. So if I multiply the top by -8, that gives me 24b minus 80w equal to, oh gosh, what is that, -872. Okay, the bottom, if I multiply by 3, 24b plus 36w equal to, and that one's 531. I did it on my calculator already. So if I add these, that gives me -44w. Just be careful with your signs. This is -341. And if we divide that out, we get 7.75. So that's how much they're earning per hour at the water park. So then I got to plug it back into one of these, so it doesn't really matter. I'm going to do the one with the smaller numbers, 3b plus 10 times 7.75 equal 109. And try to solve this to find out, let's see, subtract that. That's 3150. So I get B is 1050. All right, so that means that he's earning $7.75 per hour. Oh wait, that's the water park. At the water park. And $10.50 an hour babysitting. And babysitting is much harder than working at the water park, I would think. I don't know if any of y'all babysat, but it's a tough job, y'all. It's not easy. You earn your keep for sure. All right, last one, number 11. Kent has a collection of pennies and nickels with a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? All right, so I'm going to do P is pennies. And N is nickels. So pennies and nickels. So let's see, 0.01 for the pennies plus 0.05 for the nickels, because that's how much they're worth, is equal to $1.98. And then the number of pennies is 5 less than twice the number of nickels. So 2n minus 5. All right, so there's our system of equations. Now, I'm going to use substitution since P is already isolated right here. Then I'm just going to plug it into the other equation. So that would give me, let me move this up, that would give me 0.01 times 2n minus 5 plus 0.05 n equal 1.98. All right, so I've got distributive property right here, which gives me this. And then when I add my like terms, I get 0.07. If I add the ends together. Okay, now I'm going to add that constant to the other side. Divide by 0.07 and I get 29. So there's 29 nickels. And if I know there's 29 nickels, I can plug it back in right here and find out that there's 53 pennies. So 53 pennies and 29 nickels. Alrighty, we are done.